Hi boys and girls, thanks for taking the time to watch this video on distributive property. You're certainly helping me out by doing it for homework instead of in class. I figured I'd do it this way because you did a lot of this in 5th grade and you might recognize this. And if you watch a minute or two of the video and you feel like you can do the rest without any some help, feel free to do so. So I'm going to talk about the first 2 examples on the front side. I'll do a video for, and when I'm done with those 2 exercises, I'm going to try 2 examples on the back side. After that, you guys will be on your own. And what I'll do is I'll post the answers to those other exercises I don't show the video of, so you can check your answers. Okay, so let's begin. So if you read the directions, it kind of gives you a hint as to how you're going to do this. You need to find the greatest common factor first from the 2 numbers and rewrite the expression using the distributive property. So if I want to do 12 plus 10, we're going to use the distributive property to figure that out. The first thing you need to do is to find the greatest common factor of 12 and 18. What that means is what is the largest number you can divide both 12 and 18 by. So this one you could probably do mentally, but later on you might see some that you can't. Remember the T-chart? That's where you list all the factors of 12, starting with 1. Okay, and do the same thing for 18. So the greatest common factor is the largest number you can divide both 12 and 18 by. So what's the greatest common factor? 6. And you can see in this exercise, I did it for you to find the greatest common factor. Now you have to figure out, okay, what do you multiply 6 by to get 12? So you do 12 divided by 6 to get 2, and 18 divided by 6 is 3. So when we're writing our distributive property expression, we can use parentheses in multiplication. So we're going to rewrite this by putting the greatest common factor on the outside. That's why it says GCF. Your GCF always goes outside. On the inside is what do you multiply 6 by to get 12? 2. And you got that right here. Plus, what do you multiply 6 by to get 18? Hopefully you say 3. And if you don't believe me that these are both equivalent expressions, let's try it out. We know that 12 plus 18 is 30. Let's see if we get 30 over here. Order of operations, that's to do parentheses. 2 plus 3 is 5. 6 times 5 is 30. So this is just showing 2 different expressions that are equivalent using this distributive property. So let's try the next one. This time, I don't give you the greatest common factor. So you have to figure out what is the greatest common factor of 42 and 14. Now, you might be able to do this mentally. If you can't, we can do the T-chart to help us. So I would do the largest one first. 1, 42 is even, so it's 2, 21. I know it's divisible by 3 because I see 21 on there, which is divisible by 3. Another reason we know is 4 plus 2 is 6, so it's divisible by 3. And 3 times 14. So you can kind of already see what your greatest common factor would have to be. It would have to be 14. So write 14 here. Your greatest common factor always goes outside the parentheses. That's what you're going to multiply by. Now ask yourself, what do you multiply 14 by to get 42? The 42 divided by 14, and you can see it's in your T-chart already, is 3. That 3 goes inside. What do you multiply 14 by to get 14? Well, that's pretty easy. 1. Okay, so both these expressions should be equivalent. So you can double check that by doing 14 times 4, okay, which is 56. If you did 42 plus 14, you would get 56 as well. Okay, so if you look at the part C, I scaffolded it for you, helping you how to set it up. So find the greatest common factor of 36 and 27, fill in the blank. And if you see in D and E, I take those steps away. So feel free to use the same method I did up here for you. Okay? All right. The next page on the